As we can clearly observe these days, the weather pattern across Europe has become increasingly stable. After a winter marked by abrupt reversals, frequent cold outbreaks, and significantly more snowfall than many would have expected, the atmosphere now seems almost calm. Temperatures have moderated, pressure systems appear more organized, and large-scale instability has noticeably diminished. This raises an important question: how can such a rapid and seemingly uniform stabilization take place in such a short period of time? Just weeks ago, the continent was under repeated cold intrusions. Now, much of Europe is experiencing quiet, settled conditions. The answer lies in the nature of the atmosphere itself. The atmosphere is part of Earth's broader system of natural balances. Like many natural systems, it constantly attempts to restore equilibrium. When circulation patterns become too disrupted for too long, compensatory mechanisms often emerge, sometimes precisely when we least expect them. Throughout much of the winter, conditions were paradoxical. At a time when a strong tropospheric polar vortex would typically dominate and confine cold air to higher latitudes, the vortex instead remained unexpectedly weak. This weakness allowed repeated and persistent polar air intrusions towards southern latitudes. Cold Arctic air spilled into Europe more frequently than seasonal norms would suggest. Blocking highs and disrupted jet stream patterns enabled these outbreaks to linger, reinforcing winter conditions across large areas. Now, as spring gradually asserts itself, the background dynamics are shifting. Days are becoming longer, solar radiation is increasing, more heat is being transported toward higher latitudes. And interestingly, instead of weakening the polar vortex further, this redistribution of energy appears to be helping it reorganize. What we are observing now is a polar vortex that appears to be regaining coherence. It is not necessarily stronger than average in absolute terms, but it is functioning more efficiently than it did during the core winter months. This recovery is clearly visible in the Arctic Oscillation Index, which is rising sharply toward positive values. A positive Arctic oscillation phase corresponds to stronger west to east circulation, intensified westerly winds across the mid-latitudes. When the Arctic oscillation turns positive, the polar jet stream becomes more consolidated and faster. The high-latitude cold air remains more effectively confined above polar and subpolar regions, rather than spilling southward. Another visible feature of this transition is the reduced spatial footprint of the vortex. On 500 hectopascals geopotential height maps, the vortex now appears more compact, a tighter, more clearly defined circulation centered over the Arctic. Instead of sprawling across large portions of the northern hemisphere, the cold core circulation has contracted. This contraction allows mid-latitude flow patterns to become more zonal and less distorted. In practical terms, this means fewer deep troughs extending far into southern Europe, and fewer meridional exchanges between Arctic and subtropical air masses. As the polar vortex retracts and consolidates, it creates room for another atmospheric player to expand: subtropical high-pressure systems. These highs are part of the descending branch of the Hadley circulation, regions where air sinks, dries, and stabilizes. With the polar circulation now more confined to higher latitudes, subtropical ridging is able to extend farther north than it did during winter. At ground level, this translates into widespread anticyclonic conditions. High-pressure systems promote weak horizontal air movement, reduced cloud cover, and abundant sunshine during the day. Under clear skies, daytime temperatures can rise efficiently due to solar heating. However, the same clear conditions also allow for significant nocturnal radiative cooling. That is why nights can still feel chilly, and in some regions, fog or low stratus clouds may form locally during the early morning hours. This diurnal contrast, mild afternoons and cool nights, is typical of stable springtime anticyclonic regimes. This configuration is often referred to as a European blocking pattern. In this setup, persistent high-pressure centers establish themselves over Central Europe, often around southern Germany, the Alps, or Slovakia. These highs act as atmospheric shields. They prevent Atlantic disturbances from penetrating deeply into the continent and block significant Arctic air advection from the north. Unlike the winter blocking episodes that redirected cold air southward, the current highs are positioned in a way that maintains stability rather than instability. In summary, the stabilization we are witnessing is not accidental. It is the result of a reorganized polar vortex, a strongly positive Arctic oscillation, and the northward expansion of subtropical high pressure. After a winter defined by volatility and repeated cold incursions, the atmosphere is temporarily restoring balance. Whether this stability will persist deep into spring remains to be seen. But for now, Europe finds itself under a calmer sky, not because winter disappeared suddenly, but because the larger atmospheric machinery has shifted into a more organized configuration. Your support means a lot to us, so if you randomly stumbled across this video, and you made it to here, we would deeply appreciate if you would leave a like to the video and subscribe to our channel. Thank you very much for your attention.